Here's 2015 question 2. Clearly it's an area and volume problem, okay? So they don't tell you which one's which. They tell you that f of x and g of x are these, okay? But not explicitly what it is on the graph. So you do have to understand which one is which, okay? So if you do it on your calculator, if you have a graphing color calculator, it'll be pretty easy to do. But basically, this top one here is g of x, okay? And that one down here should be f of x. Okay, so if you notice, we're trying to find the sum of the areas of R and S. So we're pretty much adding up these two areas. But if you notice, in region R, your top is your g of x, your bottom is your f of x. But the moment you pass this intersection point, your top and bottom changes. So this is going to require us to set up two different integrals here, okay? We actually have to go from 0 to something of g of x minus f of x dx, okay? Then we're going to add the integral f of x minus g of x from somewhere to 2. If you notice, 2 is right where it ends, okay? So the only thing left here is, well, where do we stop for the first integral? We go from 0 all the way to that intersection point right there. So how do we do that? If you graph this as y1 and y2, you graph it, you calculate your intersection, okay? So you would just go to second, trace 5, and then they'll ask you for your first equation, second equation, and take guess. In this case, you would just press enter, enter, and if you would eyeball it, this intersection looks like it's somewhere around 1. Okay? I know it's in between 0 and 2, so I'm just going to guess 1. So they should give you this at the bottom of your calculator right here. So we know we're going to go from 0 all the way to 1.032832. You could store that by going quit, store, and then picking your letter. Or you could just type out the whole thing, but that's basically what they did right here. I'll leave it up to you guys on what you want to do. So where you stopped is where you started for the second integral. Okay, quick plug and chug. There's an easy 4 points right there. Okay, here we go, part B. The region S, so only S is the base of a solid whose cross sections are perpendicular to the x-axis. Okay, so remember, perpendicular to the x-axis, meaning we integrate with x. Okay, and we know that the cross sections are going to be squares, so the area of a square is going to go in here, so in this case it's going to be something squared. I'll illustrate that for you guys here. So that top and bottom will give me the length of one of the sides here. So basically, all we have to do to get the length of one side is f minus g. Okay, and we would just go from that A intersection to 2, or explicitly 1.032832. Up to you. Plug and chug, you get another 3 points there. Very doable. Okay, here's the last one, part C. Let h be the vertical distance between the graphs of f and g in region S. So let me give you some space here. Okay, so let h be the vertical distance between f and g. So remember, up here was, I believe it was f, and down here was g. H is going to be your vertical distance, which is pretty much top minus bottom, okay? We want to find the rate at which h changes with respect to x. So h is going to be top minus the bottom. So Make sure you understand that first before you move on. H is going to be the vertical distance, so that's just top minus bottom. So if you want to find the derivative, H prime would just be F prime minus G prime. And specifically, you want to find the rate at 1.8. This is a quick plug and chug, so I would type out y1. Whoops, hang on. I would type out math 8 d over dx of y1 evaluated at 1.8 minus math 8 d over dx of y2 evaluated at 1.8. Okay? A lot of computation, but remember you're not doing this by hand, so it's a lot easier. That's pretty much it. Very doable.